Math 1, Features of Functions Practice. So here's the rundown. It's going to go similar to the way the daily check and the warm-up went. You guys are going to have time to do a problem, and then we will go over the problem, and you can check to see how well you did. And hopefully as you keep going through, you get a little better. Okay. So if we take a look at this, you should have already done this, or now would be the time to pause it and to do this. Give yourselves about 5 minutes, and then we'll see how well you did. Alright, so you should have that done now. It should have been paused and you should have got that done. So let's take a look at this. So we're given the graph here, and we've got to find all these features. So let's first start with the points. Actually, let's start with the other. So looking at this, the first thing we should notice is it's got that exponential shape, doesn't it? Okay. Now, if we look left to right, is it a function? Well, if we were to draw that vertical line and run it across, it would only ever touch once, right? For every input, we're only going to get one output. So yes, it is a function. Okay, it's an exponential function, so it does have an asymptote. So where does it look like the line that it ends up touching as it goes to the left? Well, it should look like it's hitting that line of, should actually say y equals 1. Make that fix. Apparently I put an x instead of a y. So the asymptote would be at y equals 1. It's never going to cross that point there. It may look like it's touching that line, but it never will. Now, is this continuous? Remember, continuous has two parts. Does it keep going? Which, yes, this one does keep going because of these arrows. But notice that it's not connected. It's a dotted line. So that means it is not continuous. Continuous has to have all the points in between. Okay? Alright, now let's take a look. So, x-intercepts. Remember, that's where it crosses the x-axis. Because we have an asymptote here, it's never going to go below, which means there are none. Okay, sometimes that happens. Now the y-intercept. Where is it crossing the y-axis? Well, that one should be easy to see because I use Desmos, remember. That's a great graphing website or app if you download it to your phone. You can see it's kind of highlighted it for you. So what's that point? That point is 0 for the x value, 2 for the y value, so 0, 2. Now, maximum. It's going to keep going up, so there is no maximum. Minimum, I know you'll want to say the minimum should be this asymptote, but it actually, the way it goes, mathematically speaking, it gets closer and closer to that line, but never touches it. But it does keep going down, so there's actually no minimum either. Okay? Now those were our point notation. Now let's look at the interval notation. So remember, with intervals and with the brackets, it's one variable we're talking about. We're not doing the two variables like a x and a y like we do on the points. Okay? So on all of them, you're going to do the x value except for the range. The range is the only one where you're doing the y values, but the rest are the x values. So, increasing. As we look left to right, is it going up? Yeah, it's going up the whole time, right? So, as we go to the left, as we start, we call that negative infinity. So we start at negative infinity, okay? And then, we just keep going to the right. It's going to keep going up as we go to the right, so we keep going until we call that positive infinity. So it'd be negative infinity to positive infinity. That's pretty much the whole graph, right? So is it ever decreasing? Nope, never decreasing. Okay. Now, positive and negative. Positive, remember, is above the x-axis, negative below. So this is always above the x-axis, so from negative infinity to positive infinity, it's always above the x-axis. Apparently I should have made my brackets a little bigger for myself. So is it ever negative? Nope, never. Okay. Now domain, remember, domain is all the x values. Well, this keeps going to the left and keeps going to the right, so it includes all the x values. So from negative infinity to positive infinity would include everything. Then the range. The range is never going to go below 1. That's our lowest point. So we can put a 1 here as kind of our boundary. But it's going to keep going up and up until we get to positive infinity. So it would go from 1 to positive infinity. Okay? So there's our first one. Hopefully you did it pretty well. If you need a second, ask your guest teacher to pause it so that you can get this all down. Hopefully you noticed any mistakes in your thinking or in your actual doing of this, if you had any. Hopefully you didn't, but if you did, that's alright. That's why we're doing this a piece at a time. Alright, now go to the next one. Okay, so pause the video, take a few minutes, about 5 minutes, and do this one. So pause the video now. Alright, so you should have had some time to do that one. Let's see how we can do on this one. Alright, first thing to probably notice is this point stops right here. Okay, it might be hard to tell on your graph, but it does. Okay, so let's start again with the others. So, is this continuous? Well, it keeps going to the left. It does stop here, but because it's not dotted, it contains all the points here, you could say yes, it's continuous. Some may argue that because of this point right here, it's not, but I would call it continuous. Is it a function? Well, for every input, is there only one output? In other words, for the graph, could you do that vertical line test? Yeah, if you ran a line across here, it would only ever touch in one place. So yes, it's a function. Does it have an asymptote? Well, it's definitely not exponential, so we don't need to worry about that one. Alright, now let's take a look at our points. So remember, the points are an x and a y. So, do we have any x-intercepts? Yeah, we actually have two of them, don't we? One right here at -5, 0. And then we actually have another one, don't we? At about, let's say, 4.75 and 0. A function can have more than one x-intercept. Okay, now, y-intercept, do we have one of those? We do, right here at 0, 5. Now, do we have a maximum, a highest point? We do right up here, right? And that would be at -2, 6, the highest point. Do we have a minimum? Okay, looking at that one, it keeps going down, so technically no, though you could argue that there's a relative, a local minimum right here. So if you put 6, -5, I would accept that. You'd probably want to put a relative minimum, but you should probably put none, because it does keep going down. Alright? Okay, now let's take a look at these intervals. Remember, intervals deal with one variable, range deals with y, the rest are going to use the x's. Just like on a football field, that yardage line, we don't care how high or low, we're just looking at the yardage line. So, increasing. Well, if we go left to right, if we started clear out here at -infinity and went right, because of that arrow, it would always be increasing until it gets to this point. So from -infinity, it increases until it gets to the x of -2. So -infinity to -2. Now decreasing starts here, and then it starts decreasing until we get to here. So it starts at -2 and decreases till we get to 6. So we'd write -2 to 6. Okay. Now, is it positive? Let's clear this a bit. I guess, where is it positive? Remember, positive is above the x-axis, so up here. So from this point, our x-intercept to our other x-intercept, it is positive, right? But we're just doing the x values, so from -5 to 4.75. It's going to be positive, which means it's negative everywhere else. So from -infinity till we get to -5, it's negative. Okay. Now, when you have more than one area like this, but it's separated, because we go to 4.75 till we get to 6, right? So what you do is after you end your bracket, you do a little U, which means there's more, and then it would be 4.75 to 6. So sometimes your intervals, especially with increasing and decreasing, you'll run into that issue, okay? Alright. Now for our domain, okay, how far to the left did it go? Well, it went out to -infinity, and then it keeps going until it gets to 6. So our domain, -infinity to +6. Our range, remember, how low did it go? Well, it keeps going down to -infinity, so it starts at -infinity and makes it up to +6. So negative infinity to 6. And there's the second one. Hopefully you did better on this one. And if not, well, keep trying. Now, on the next ones, we're actually going to give you the features and have you draw the graph. So it may not look exactly like this in some points, but it should be pretty close. Okay? Now, here's the thing. If we don't quite have enough time in class, make sure you take this home and finish it at home. And chances are, hopefully you're paying attention, there'll be some sort of quiz, some sort of way for me to check to make sure you guys are getting this when I get back next week. So, let's start off with the points. They're probably easiest. So we've got an x-intercept at negative 5, 0. We've got a y-intercept at 1, 0, 1. We've got a maximum at 7 and 2.5. So 7 up to 2.5, about right there. And we've got a minimum at negative 6, negative 2.5, which would be about right there. Okay? Now, that gives us some points. It says it's not continuous, so it's got endpoints, and it might not be the whole line, it might be dotted. But it is a function, so it's not going to curl around it. It has no asymptote, so we know it's not exponential. Now, for increasing is going to happen from negative 6 to 7. So from negative 6 to 7, it's going to be going up. Okay? Then it's decreasing from 7 to 9. So apparently we needed to add to our graph a 9. So from here to here, it's going to be going down. Okay? It's positive from negative 5 to 9. So from negative 5 to 9, it's going to stay. So it's never going to cross the x-axis when it's coming down. Okay. Now the domain is negative 6 to 9, so it's never going to go beyond these 2 points. Okay, we'll see our graph within that whole area. The range is from negative 2.5 to 2.5, so it's never going to go below that or above here. So it should probably look something like this. So we start at negative 6, draw some dotted lines going through our points till we get to that maximum. Then it's going to come down. We don't know how sharp, but it's gonna stop there at 9. I shouldn't have went further. So it should look something like that. Okay. So hopefully you guys did pretty good on it. Got something similar to this. Okay. Now let's see exactly what it looks like. I graphed this and then did the feature. So let's see how I did. Well, not too bad, right? I went a little steeper right here, but not too bad. Now you'll probably say, well, duh, Mr. Ios, of course you should have got it right because you're the one that did the whole thing. Yeah, but hopefully you got something pretty similar to that. Okay? Alright, last one. Hopefully you guys got time to work on this one. So pause it right now. Okay, let's take a look at this one and do as best we can. I'll go as fast as I can because you probably are getting pretty close to being out of time. So 2x intercepts at negative 2 and at negative 0.5. Okay, so negative 2 and negative 0.5. Y-intercept at 0, 1. Okay, maximum at 3, 7. Oh, it jumps up high, doesn't it? So that's my highest point. So look at our range, negative 1 to 7. That's the highest point, right? Makes sense, our maximum, highest point. Okay, our minimum, negative 1, negative 1. So our minimum's down here. And once again, that's our lowest point. Now our domain, negative 10 to 6. So we'll actually go out here, negative 9, negative 10. So we'll go from here to positive 6. So that's where our graph should live, within that area. Okay. Now, it is continuous, so we'll draw the line. It is a function, so it won't curl back. It's not exponential because there's no asymptote. So we've kind of dealt with the range. We know it's going from here up to here. So it's almost like you could make a little box here. And you know that our graph is going to be within this box here. Okay? You kind of think of it that way. Now it's increasing from negative 1 to 3. So that's our lowest point. So it's going to be going up here like this somehow, right? Okay? decreasing in two places. Okay, it's positive from -10 to -2. So -10 is going to have to start somewhere up here, and it's going to go down to -2. Okay, where it's going to start, I don't see any indication of where it's going to start, but it's decreasing, so I know it's going to come like this and somehow be up, but it can't go higher than 7, so maybe right about there. Okay, it's also positive from -0.5 to 6, so in this area it's also going to still be positive, it won't drop below. Okay, negative from -2 to 2.5, so that little area, we got that. So now it's decreasing from 3 to 6, so somehow it's coming down too. Okay, so it should look something kind of like that. Okay, now should we see how I did? Alright, so here's what it should have looked like. Okay, so I obviously went way too high at -10, and I kind of curled down, which hard to tell, right? And I went up and then kind of curled again. Okay, so not quite exactly the way we did it, but if you'll notice, it is that same basic shape. Okay, so that's how we can use those features to help us understand the graphs, to talk about them. If you still didn't have enough time, make sure you watch this over the weekend, finish this. If you got it finished, hopefully you did, you can hand it in now, and have a good weekend.